Hello, YouTube. This is Umozo3. It's been a few weeks since I've done a Java video. In fact, maybe closer to a month. But anyway, in the previous lesson, we talked essentially about file input and output. And we said basically that in our Java programs, not only can we just print things to a console, but we can do something a little bit more interesting, right? We could actually go ahead and create a text file, and then we could write to a text file, and then we could read from a text file. And we talked about how to basically do that in the previous video, and it probably deserves a little bit of a review. So anyway, I think about 2 lessons ago, we talked about system.out.printf. 2 or 3 lessons ago, we talked about this formatted print. And we already are familiar with system.out.println, which we've used a lot, and system.out.print, which is similar. The only difference is that it does not print a new line at the end of whatever you're trying to print. But with system.out.printf, remember we have a formatted string, and essentially we can have a percent, and then we can basically specify spacing, right? And so if we have percent 10.3f, this specifies that we want to set aside 10 units of space for this for a floating point number, right? And that means that we're going to have 3 spaces of precision after the radix point, after the decimal point. Okay, and the percent 15s, that means that for the next string, we're going to leave 15 characters of space. Even if this word, this string here, which is just the word spacing, doesn't take up 15 characters, we're still going to allot 15 characters of space for it, right? And then you could have another string, right, which we just called another string coincidentally, and that would just be percent %s. And so hopefully you can understand the lineup here. And then if you wanted to have a system.out.printfln, if you wanted to print a new line at the end of your formatted print, then you could just put a \n here at the end of your string, right? And then if you didn't have a string here, you could make it separate, right? So you could say comma and then \n, and then you would just have to go ahead and insert another percent %s here in your system.out.printf to indicate that you want to print a new line. But anyway, I think that's enough of a review on that. So percent %s for passing in a string, percent %d for passing in an int, percent %f for passing in a float. Okay, and then we also talked about the do while loop, and we said the only difference between a while loop and a do while loop is that the do while loop will execute before the Boolean is checked. So if you have do while, that's sort of equivalent to running the loop body and then doing a traditional while loop. So hopefully that's clear to you and you can understand when these 2 types of loops, usually they're pretty similar and they're going to be kind of 99% in sync with each other, but you can understand that there would be an issue if the main Boolean that we're starting out with is not true, because then the while loop would not run, but the do while loop would run once. So hopefully that's clear to you. And we said that file input and output allows us to create, write to, and read from files in Java. And we said there are about 10 steps. So you can see there's a lot of text here, but it kind of fits on the screen right now. And so you would have to, the first thing you have to do is import 5 classes, right? And so if you scroll all the way up, remember we imported these 5 things: file, file writer, IO exception, file not found exception, and scanner. Those are 5 important classes in Java. And you can go ahead and look at the API. You can go ahead and Google these things and you can learn about how these different classes work in Java, but you have to import those things. That's step 1. Step 2, you have to use a scanner instance to, and then this is sort of optional, but if you wanted to ask the user for what they wanted to create the text file as, then you would just prompt them with a question. What do you want to create? What do you want the name of a new text file to be? And then the person can enter that, and then that will be saved as a string. And then basically what we did is when we scroll down here, what we do is we see that the response is going to be basically what the new file is created as, because we're going to say file f equals new file of response, and the response string was set equal to whatever the user entered when he or she was prompted for a file name. So hopefully that's clear to you, but that would be step 2, right? And then in step 3, basically what we did is we said that we need to create a file object based on the file name. So that's what we do in a try block. And so we instantiate a file object with a string representing the name of the file to create, okay? And that will show up in the same folder as the Java code we've been writing. So hopefully that's clear to you, but it has to go in a try block. And you'd say file f equals new file of response. And then you would say if f.create new file, you would say system.out.println of file created, right? But then otherwise you would say it already exists, right? So you want to create the file if it exists. If it doesn't exist, but if it already exists, then you wouldn't want to create the file, right? Because then that would just lead to sort of a duplicate, okay? And so then what you would do is that you would put this into a try catch block. And we've talked about exceptions a few times. I think we started talking about exceptions pretty recently in like lesson 43 or 44. but we would say catch of IO exception E, and then you could just say system.out.println and just say something like a file create error occurred. And we've talked about how these try catch blocks will prevent exceptions. So will prevent the code from erroring out, right? And it'll still allow something to be successfully printed to the console, even if things didn't go as planned. And then in step 5, you know, we're going to have another try block. So that was sort of for creating a text file, but now we want to instantiate a file writer object with the string representing the name of the file to write to. Okay, and so what you would want to do is you create a file writer object. And so we scroll all the way down, and you say try, and then you're going to create a new file writer object. Okay, and then what you would do is you would basically want to go ahead and write things to it, okay? And so the way that you would do that is you would use the write command. So you'd say w.write of, and then some string. So I just have write 1 here, but basically what we were doing is we were asking the user over and over again to input words onto the text file, right? And we saw an example of that, but this is not the easiest example, right? This does a lot of user input and do while loops and things like that. But the point is that you would create a file writer object like W, and then you would say w.write of, and then you would pass in a string to write to that particular text file. So hopefully that's clear to you. And then you have to remember to close it. Remember, after you're done writing things to the file writer instance, you have to close the file writer instance. And again, all of this has to happen in the context of the second try catch block. So now what you would do is we say call write of X on user specified or constant string X on your file writer instance from step 5, right? That's what we just talked about. And then call close. So call close on your file writer instance and verify that the words have been written to the file. And then there's one more try catch block. So we said in the third try catch block, so we've already talked about creating the file. We've already talked about writing to the file. Now we need to talk about reading from the file. So in try number 3, we're going to do 3 things. We're going to create a file object based on the file name. Same thing as in step 3. We're going to see that again. We're going to create a scanner object parameterized by that file object, you know. So step 8 obviously has to come before step 9 because step 9 requires step 8. And then finally, the last thing that you do is you're going to say while t.hasNextLine system.out.println of t.nextLine. So we can go ahead and scroll down and remind ourselves of what that looks like. So you're going to say try, and then file z equals new file of response. This is the same as step 3. Okay, and then you could say scanner t equals new scanner of z. So this would be step 9. So after you've written this, you're like 90% done. And then this is the last step. So you would say while t.hasNextLine system.out.println of t.nextLine. So hopefully that's clear to you. And we went through the steps, and we saw how basically if you have these 3 try catch statements, one of them creates the file, one of them writes to the file, and one of them reads from the file. And that would basically be the logical ordering. That would be the logical way, the intuitive way that you would be working with file input and output. So hopefully that's clear to you. What I want to talk about in this video is something called threading. Okay, and so basically Java is called a multi-threaded programming language, and that means that it can run multiple components of a computer program concurrently. Okay, and so if you have multiple instruction sets in a Java program, you know, it doesn't necessarily just have to take one at a time. Maybe it can distribute its memory. Maybe it can distribute its memory and its processing in such a way that it can actually run tasks concurrently. And that's called threading. Okay, and there's probably Wikipedia articles about it, and you can learn, you know, as much as you desire about this stuff. But basically what we could do here is, I'm sort of getting blocked here, but what we could do is you can learn all about threading. You know, it wouldn't hurt to start with just a Wikipedia article, right? And you'd have to be specific enough, right? But you go to threading and then Wikipedia, and then obviously we'd probably want the programming technique, right? So you'd want the programming technique here, or so thread computing. Okay, and so basically a thread is the execution of the smallest sequence of programmed instructions that can be managed independently by a scheduler, which is typically part of the operating system. So basically it just means that you're trying to execute a process concurrently, okay? And so there's multiple threads, there's multiple things that you're sort of trying to do at the same time. And the goal is going to be to allocate memory, to share memory so that, you know, so that you can run different processes at the same time. We're going to talk about 2 ways to do that. We're going to talk about 2 ways to do threading in Java. There's 2 options for it, and it's not going to be a lot of code. It'll probably be an easier video than the previous one. But we're going to talk about 2 ways that we can have threading in Java, okay? And we need to look at a couple of APIs for this video, so it'll be helpful to pull up some Blackle tabs or Google tabs if you insist. But what we would do here is there's 2 options. There's 2 ways to do a thread, to do threading. So the first option is to extend the thread class. We've already talked about subclasses and inheritance and polymorphism, and we said that basically a class can be a subclass of another class. And so that means that it will take all of the methods and the variables and the functionality from the superclass. But then at that point, it has its own autonomy to, override some of the methods or provide some of its own in the subclass. And we talked about that for multiple videos, starting from like lesson 31 or 32, for multiple lessons, we talked about that. But what we would have to do, so the first option for threading is to extend the thread class. So you would literally create a class that's a subclass of thread. Okay, well, what's thread? Well, let's go take a look at that. So thread is actually an important class in Java. Okay, so you would literally just go into blackle.com and you would do thread Java API. So you can Google this, you can Blackle this, you do thread Java API. And we just want to learn about the documentation for the thread class. Okay, and it says a thread is a thread of execution in a program. A thread is a thread. That's super helpful, right? But every thread has a priority. Threads with higher priority are executed in preference to threads with lower priority, right? And so the higher priority threads are preferred. They'll run first, okay? And so hopefully that makes sense to you. But this is a class in Java, okay? And already has a lot of functions and has a lot of constructors. There's a whole lot of ways to create a thread instance, right? There's a default constructor, obviously, which doesn't accept any parameters. But you can also pass in, apparently a runnable object, right? Or you could pass in a string, or you could pass in apparently a threaded group object and a runnable object. But anyway, these are different constructors. And then there's all kinds of different methods, right? And so there's different methods that you can see here. There's a start method and a run method and a resume method. So these are kind of interesting. Interrupt and is alive and join and sleep and things like that. So these seem kind of interesting, and some of these seem like they would be pertinent to the execution of a Java program. But anyway, the first way that you can thread is you can extend the thread class. And so what I do here is I'm going to say public class thread me, just any subclass, you can call it whatever you want, but you need to say extends thread, because we're going to take the functionality from the thread class and we're actually going to override the run method. So you know that when a superclass has a particular method, the subclass can override it, right? The subclass can provide like alternative functionality for that method. So if you look at the run function here, if you look at the run method, thread has a run method, okay? And if this thread was constructed, then that runnable object's run method is called. So basically what this means is you would basically be overriding the run function from thread, and you would be using this one instead. So what you have to do is you have to extend the thread class. You're going to define a run method. So within the subclass of thread, you'll just have one method. There's literally one instance method here. There's one instance method. It's a void method, doesn't accept any parameters. This is a very simple subclass, right? And it just said system.out.println of sup. So it's just going to print a word onto the console. Okay, and you define the run method. And so these are the first two steps. And then what you would do is you would create an instance of threads of the thread subclass, right? So here we created a subclass of thread and we called it threadme. Okay, and so what we're going to do is we're going to create an instance of threadme. We're going to create a threadme object. And then we're going to call the start method on the threadme object. Okay, so now what we can do, well, what would the start method do, right? Because here, if we're saying that we want to call the start method of threadme doesn't have a start method, it only has a run method. But remember, it's extending thread. It's a subclass of thread. And so if threadme doesn't provide a start method, then threadme will use threads. It will use the superclass's start method. And so now you can go ahead and look at the documentation for that, but you'd have to look at the start method, right? And it says causes the thread to begin execution. And so that's basically what would be happening if we went ahead and called start, is it would actually run this thread. Okay, so what we're going to do, so hopefully you can understand this. You need to write public class, and then you can call it whatever you want, but it needs to be a subclass of thread. So call it whatever you want, and then write extends thread. And then you're going to have a method called run. And you're going to say public void run, and then whatever you want, whatever instructions you want to have executed, you can put them here. And I have a very simple example here. I just print one word on the console, system.out.println of sup. Okay, so what we're going to do is I want to show you these two steps. So we need to create an instance of this subclass, and then we need to call the start method. So now what I'm going to do is I'm going to move out of the threadme class, and I'm going to go into a separate class, sort of like a tester class. And I'm going to call it tryme. Okay, so now we're in another class called tryme. It's just a separate class, okay, but tryme, and it just has a main method in it. Okay, so we don't need to instantiate it or anything like that. It's only like it's sort of a tester class, right? It's another class that's going to test out the threadme. It's going to test out the subclass of thread that we just created. So what we're going to do is we're going to say threadme w. And so this declares an instance of the subclass of thread, okay? Because we just created a subclass of the thread class. And then within that subclass, we just declared an instance of it. So we say thread me W, okay? And then we're gonna say W equals new thread me, okay? So this would initialize, declares and initializes an instance of the subclass, okay? And then what you can do is you call the start method, and that's all there is to it. So what did we do? We extended thread, we wrote a run method where it's just gonna say system.out.println of sup, and then we create an instance of that subclass of thread, and then we call the start instance method on that instance. So you say thread me W equals new thread me. You can do it in all in one line if you prefer. And then you would just say w.start. Okay, so then we can go ahead and compile it, and then we can go ahead and run it, and it just says sup, and it was able to execute that program instruction. Okay, so hopefully you can understand the 4 steps. You extend thread, you make a run method, you create an instance of the subclass that, the subclass, and then you call a start method on that instance. That's all there is to it. There's 4 simple steps, and hopefully you can understand how this is working. There's another way to go ahead and do threading, and it's actually a better way. It's actually a preferred way to do threading, but it's very similar. And so we actually have to think about another approach. There's another way to do threading, and there's another way to have elements of a program run concurrently. And so we've already talked about extending a subclass, or we've already talked about basically inheriting a class, right? Extending a class and making a subclass, and that's what we did here. But we also talked about interfaces, remember? And we said that we can also implement an interface, and that means that we need to specify definitions for all of the abstract methods in the interface, and we saw examples of that in previous videos. But the other option, if you don't want to extend the thread class, so if you don't want to make a subclass of thread, and then, create an instance of that subclass, there's another way to do all of this, and that's to implement Runnable. So you need to go ahead and be familiar with the Runnable interface. So you do Runnable Java API. You can Google this or Blackle this, but you go to Runnable, right? And so this is an interface. The Runnable interface should be implemented by any class whose instances are intended to be executed by a thread. So this is sort of tied in with the concept of threading, right? And so we're trying to execute code here. So we would implement Runnable. So you have to have a class that implements that interface. You would say public class, call whatever you want, and then you would say implements Runnable. That's the first step. And then you need to define a run method. So then within the class that's going to implement Runnable. So here we are now. So we say public class load me implements Runnable, and then you're going to go ahead and create a run method, right? And so we would just create a run method. This step is identical. You're just going to specify what program instructions you want to have happen. So just like how we had remember in thread me in the subclass of thread, we made a run method. Same thing here. We're going to create a class that implements the Runnable interface. And then within this class that's implementing the Runnable interface, we need to make a run method. And so you say public void run, and then you could just say system.out.println of hockey stick. Just a very simple program. And then what you're going to do, and so the last 2 steps is you need to create a thread instance parameterized by the instance of the implementing subclass. And then you need to call the start method on it. So what we need to do is we need to think about the constructors here, right? Because if you're trying to create a thread, what you can do is you can actually pass it a Runnable. You can pass it a Runnable. So what you would do is you would implement Runnable, you define a run method, right? We've already seen this. So we have a class called loadMe, and it implements Runnable, and it has a run method, right? Just like how threadMe had a run method, loadMe is going to have a run method too. But we're going to call it in a different way. So instead of just creating an instance of the subclass, then calling the start method, we need to create a thread instance parameterized by the instance of the implementing class. So by the class that implemented Runnable, we need to create a thread instance where we pass in an instance of the class that implemented Runnable, and then we call the start method on the thread instance. So let me show you what I mean by that in the last 60 seconds. What we're going to do is we're going to take out the first example, right? So we've already talked about that, but there's another way to do threading. And you could say load me y equals new load me. So this is an instance of the class that implemented the Runnable interface. Remember, we called it load me, and we said that load me is to implement Runnable. So hopefully that's clear to you. But you're going to say load me y equals new load me, right? And you're just going to call the default constructor. There's no parameters yet. But then you create a thread object. So you say thread z equals new thread of y, okay? And you need to pass in an instance of the class that implemented Runnable. So in this case, it would be load me, and you pass in an instance of load me. So you say thread Z equals new thread of Y, and then you would just say Z.start. So you would call the start method on that thread instance, okay? So now you go ahead and run it, and this is just another way to do threading, and it's slightly more complicated, but you would get the same result, and you would see hockey stick printed on the console. So those are two approaches to threading, and we can go ahead and review those in the next video for a little bit more clarity. But from UMills03, thanks for watching, and please subscribe.